Howdy folks, welcome to this first video here. So in this video I'm just going to be going through the practice test 1 for the math class. So again, this is just how I would go about solving the problems. Again, I recognize there are many different ways you can solve many of the great problems with mathematics. So your way might be a little bit different than my way. Also, the way the problems are algorithmically generated, your numbers might be a little bit different than my numbers. So don't expect the exact answer to your specific question be here in here, but hopefully it can kind of guide you as how to solve the type of problem that you might be encountering on this practice exam as well as the actual exam. So if you go to the Pearson website, so again, you go ahead and access your course. And again, on the left-hand side, you should see the homework. So go ahead and click on that. And then if you don't see it, you should see this little drop-down menu here that says homework and then all chapters. So if you click on the drop-down menu and choose all assignments, you should see practice test 1 there. So go ahead and click on that. And yeah, go ahead and click start test. All right, so this first question here is dealing with, I'm going to go ahead and move my webcam there, that way I can see the next button. So this first problem here is dealing with solving linear equations in one variable. So here if I have the equation 7 times the quantity x plus 4 equals 9 times the quantity x minus 2. All right, so my first step here is I want to simplify on both sides of the equal sign. So to do that, you can distribute and then combine like terms. So you can go ahead and distribute the 7 through to each of my terms here. And we can do a similar thing with the 9 over on the right-hand side. So we have 7x plus 28 equals 9x minus 18. All right, and then we want to get everything involving our variable on one side of the equal sign and everything else over on the other side of the equal sign. So I like dealing with positive coefficients for my variable. So I'm going to go ahead and subtract the 7x from each side. I'm going to go ahead and add 18 to move the 18 over to the left-hand side. All right, so here the 7x and the minus 7x will cancel out. So you have 28 plus 18, which is going to be 36 plus 10, so 46. And then 9x minus 7x is going to be 2x. And negative 18 plus 18 are going to cancel. All right, so now we have everything involving our variable on one side, everything else over on the other side. So once you have that, you can just divide by the coefficient in front of you, or the number in front of your variable. All right, so when we take 46 divided by 2, we end up with 23 for our answer. And again, these types of problems are really nice because they kind of have a built-in check. If you're ever curious as to whether you have the right answer or not, you can always go back and just plug it into your original equation. All right, so here we have 7 times 23 plus 4. So that equals 189. And then if I do 9 times 23 minus 2, I also get 189. So that checks out. So that is going to be my final answer there. All right. So that's if you're dealing with integer coefficients or non-fractions in front of your variables. In this case, we're dealing with fractional coefficients. So slight difference here, but not too much. So here we have 1/4 x plus 1/2 equals 1/8 x minus 1/3. All right, so again, generally I prefer not to deal with fractions if I can get away with it. So generally my first step in this case would be to get rid of my denominators. So to do that, we're looking for the least common denominator between every single one of my denominators here. And to find your least common denominator, you can just start with your largest number. All right, so in this case, that's 8. And then you're just going to take multiples of 8 until eventually you come up with something that 4, 2, 8, and 3 will all go into. All right, so here we have 8. So 4 and 2 go into 8. Unfortunately, 3 does not. So then we're just going to take the next multiple of 8. So 8 times 2 is 16. 4 and 2 also go into 16. 3 does also not go into 16. So then we do 8 times 3, which would be 24, which 4 goes into 24. 2 goes into 24, 8 goes into 24, and 3 goes into 24. So that is going to be our least common denominator. So we're just going to multiply every single one of my terms by that least common denominator. I'm just going to multiply every single one of my fractions by that 24. And since all of my denominators go into 24, we're going to get some cancellation here. So we have 1 and 6. 2 goes into 24 12 times. 8 goes into 24 3 times. And 3 goes into 24 8 times. All right, so when all is said and done here, we end up with 6x plus 1 times 12, so plus 12, equals 3x minus 8. And from this point on, it's the exact same as the previous problem. So again, to solve this, we want to get everything involving our variable on one side, everything else over on the other side. So I'm just going to go ahead and subtract a 3x from each side, subtract a 12. So you have 6x minus 3x, so that's going to be 3x. And negative 8 minus 12 is going to be negative 20. And then again, we can just divide both sides by 3 in this case. So negative 20 over 3. And again, if you're ever curious as to whether you have the right answer or not, you can always go back and check in the original problem. So you have 1/4 times negative 20 over 3. It's 1/2. So we have negative 7/6. And we have 1/8. So negative 7/6 on the left-hand side. So we have 1/8 times negative 20 over 3 minus 1/3. And we get negative 7/6 again. So that checks out. So that is going to be my final answer. So negative 20 over 3. All right. All right. So the last problem we talked about had integer coefficients or fractional coefficients. So here we have fractions, but we also have a variable in the denominator. So this was known as a rational equation. Because it's an equation involving what are known as rational expressions. So it's a rational expression is just a fancy name for a fraction with a possible variable in the denominator. All right, so you have 1 over w minus 1 minus 3 over 4w minus 4 equals 1 over 4w minus 4. All right. So again, first step here is to get rid of the fractions by multiplying by your least common denominator. In this case, we're going to factor all my denominators. So before, we didn't have to worry about the different factors. So we kind of have that easy way to find your least common denominator. When you have variables in your denominators, it's a little bit more complex, more complicated there. All right, so we're going to start off, we're going to factor each of my denominators, which in this case, this one's already factored. I can factor this as 4 times w minus 1. And similarly, on the right-hand side, that's also going to be 4 times w minus 1. All right, and then your least common denominator is just going to be the product of each of your unique factors. So we have w minus 1, and then we have 4, And then here we have w minus 1, but we've already included that, so we don't need to include that twice. And yeah, same with the next one there. All right, so again, we're just going to multiply each of my terms by that least common denominator. So 4 times w minus 1, w minus 1. All right. So w minus 1s will cancel. Here, the whole thing will cancel. And similarly, here, the whole thing will cancel. All right. So what we're left with is 4, because 4 times 1 is 4, minus 3 equals 1, which regardless of what value I have for w, this is going to be a true statement. 4 minus 3 is always going to equal 1. What I choose for w doesn't matter. So as you're going through, as you're solving this, once you get to the point where you have a true statement, so where you have the same thing on both sides of the equal sign, that's when you have what's known as an identity. So in this case, this equation has an identity. And the solution set generally for an identity would be all real numbers. However, again, especially when dealing with rational equations here, we need to make sure that we don't divide by 0. So you can't have w being a number that leads to division by 0 here. So in this case, that value would be w equals 1. And yeah. So the solution set is going to be any w, but w cannot equal 1. So that is how I represent my solution set for this problem. All right. Next one here, kind of a similar problem. So again, we're dealing with a rational equation. So you have y minus 6 over y plus 3 equals 4/5. All right, so again, my least common denominator here. So in this case, both denominators are factored. My least common denominator is just going to be the product of each unique factor. So my least common denominator is going to be 5 times the quantity y minus 3. All right, so I'm just going to multiply again both sides by that 5 times y plus 3. All right, so here the y plus 3's will cancel. Here the 5 will cancel. All right, so we're left with 5 times y minus 6 equals 4 times y plus 3. So again, this is just a linear equation now. One of the main tools that we have in mathematics is the ability to sometimes break down a complicated problem into a problem that we know how to solve, or that we have the tools to solve. So that is one of the tools that we're using here. So we have this rational equation that we don't quite have the exact tools to solve right from the get-go, and we're converting this to a linear equation, which we do know how to solve. So yeah, so that's a common way to solve many different types of problems in mathematics. All right, so when we distribute the 5 through, we get 5y minus 30 equals 4y plus 12. All right, so again, subtract a 4y from each side, add 30. So you get 5y minus 4y, so that's just going to be 1y. And then 12 plus 30 is going to be 42. Oh. There we go. And again, if you're ever curious as to whether you have the right answer, you can always go back and plug it in and check. So that's what I'm going to do here. So we have 42 minus 6 divided by 42 plus 3. So I end up with 4/5, which is exactly what I should get. All right. So in this case, we have a conditional equation, and the solution set is 42. So I guess this falls under Douglas Adams' answer to the life, the universe, and everything. It's 42. So that's one possible question that could be answering for the Hitchhiker's Guide to the Galaxy fans out there. All right. So here we have 1 over x minus 2 minus 1 over x plus 2 equals 4 over x squared minus 4. All right. So again, the first step is I want to factor. This is already factored. This is factored. It's x squared minus 4, so that's the difference of squares. So this is like x squared minus 2 squared. So to factor that, you can just take x plus 2 and x minus 2. Again, that's one of those formulas that we just handy to know. So if you have a squared minus b squared, that's going to be a plus b times a minus b. Yeah, there we go. Can't really see that. Doesn't do you much good. All right. So in this case, my least common denominator is going to be x minus 2, x plus 2. And here I have x plus 2, but I've already included that. And here I have x minus 2, but I've already included that. So the last one doesn't really add too much. All right. So again, we're just going to multiply every single one of my terms by that least common denominator. So here I have x minus 2, x plus 2. Here we have x minus 2, x plus 2. And here we have x minus 2, x plus 2. All right, so here the x minus 2's will cancel. Here we have the x plus 2's will cancel. And here we have they both will end up canceling there. All right. So we end up with x plus 2 minus x minus 2 equals 4. All right, and then we have x minus x, so that's going to be 0x. There we have 2 minus a negative 2, so that's going to be 2 plus 2, so that's going to be plus 4 equals 4. All right. So in this case, again, what it looks like we have an identity because we have 4 equals 4 regardless of what value we choose for x. So in this case, we have two numbers that we need to worry about. So x can't equal positive 2, and x also can't equal negative 2. There. Solution is x, but x can't equal positive 2 or negative 2. In this case, the equation is identity. All right. All right. Y over y plus 1 equals 6 minus 3 over y plus 1. All right. All right, so here we have 3y over y plus 1 equals 6 minus 3 over y plus 1. All right, so again, least common denominator is going to be y plus 1 in this case. So I'm just going to multiply everything times y plus 1. So y plus 1 times y plus 1. There, the y plus 1's will cancel. So we have 3y equals, so then we have 6 times the quantity y plus 1 minus 3. All right, so we have 3y equals 6y plus 6 minus 3, which we can combine like terms here on the right hand side. So you have 6 minus 3 is going to be plus 3. All right, so then I can subtract a 6y from each side. So you have negative 3y equals 3. And when we divide both sides by negative 3, we end up with y equals negative 1. All right. Now, if y equals negative 1, we need to make sure that we're still not dividing by 0. So if we go back up to the top here, if I take 3y divided by y plus 1, if I plug in negative 1 in for y here, I end up dividing by 0, so we can't have that. So that answer is not going to work. So in this case, we're going to have no solution, and that's what's known as a contradiction. So here in this case, there's going to be no solution, and the equation is going to be a contradiction, or sometimes referred to as an inconsistent equation. All right. So the next type of equation we talked about solving are equations involving absolute value. All right, so we have 5 times the absolute value of y plus 5 minus 35 equals 0. All right, so my first step is I want to get it so I just have the absolute value all by itself on one side of my equal sign. So to do that, I'm just going to add a 35 to each side. And then I'm also going to divide by 5. So I end up with the absolute value of y plus 5 equals 35 over 5, which is going to be 7 there. All right, so again, the absolute value means that in kind of an informal sense, if we have a negative number, we just ignore the negative sign. So we could have y plus 5 equaling positive 7. The absolute value of positive 7 is indeed 7. We could also have y plus 5 equaling negative 7. Because again, if I take the absolute value of negative 7, again, the absolute value just kind of ignores that negative sign. So the absolute value of negative 7 is also going to end up being 7 there. All right, so then to solve for y, we can just subtract the 5 from each side. So you end up with y equals 7 minus 5, which is going to be 2. And here we end up with negative 7 minus 5, which would be negative 12. And so in this case, I end up with 2 answers. So my solution set is going to be 2, comma, negative 12. This next question here is dealing with solving a formula for a specific variable. All right, so here we have the formula C equals 7/6 times K minus 25. This doesn't look like a common formula to me, so I'm not quite sure what this represents. It probably represents a certain formula in a problem, probably not necessarily one that is necessarily common knowledge there, I don't think. Maybe I'm wrong. I don't know. I don't have a monopoly on knowledge of all the different formulas. Like I said, terrible memory when it comes to stuff like that. All right. And what do we want to solve for now? I've been talking so much that I don't know. All right. So you want to solve for k. All right. So my first step here is I'm going to get rid of the fraction in front here. So I'm just going to multiply both sides by the reciprocal of my fraction. Again, if I multiply by the reciprocal, I can cancel out. And as long as I multiply both sides by the same thing, again, I'm safe. I haven't really changed my equation at all. So you have 6c over 7 equals k minus 25. So since we don't have the 7/6 out front, we don't necessarily need to bring the parentheses along. All right. And we want to solve for k, so we want to get k all by itself. So to do that, we can just add a 25 to each side. So we end up with k equals 6c over 7 plus 25. 6c over 7 plus 25. So yeah, so the process is fairly similar. The only thing that's really changing is instead of having a numerical solution at the end, we end up with a solution containing certain variables. In this case, the variable c. All right. So this next one here, so we have d equals b plus the quantity a minus 3h. And we want to solve this for a. So you want to get a, we want to eventually end up with a equals something. All right, so my first step here would be to get it so everything containing my variable is on one side, everything else is on the other side. So I can subtract a b from each side, and I can go and distribute this h through. So you have d minus b equals, second thought, I don't think I will distribute the h through. You could. Again, there's more than one possible way that you could formulate your answer in this problem. I'm going to kind of do a similar thing to what I did up here. All right, so the next thing I'm going to do is I'm going to divide both sides by h. If you distributed the h through, then you'd add 3h to each side, and then you'd end up dividing by h. So either way, you'll end up with the same, an equivalent expression. It might look a little bit different, but it'll be the same. All right, so you have d minus b over h equals a minus 3. All right, and then again, to get a by itself, you can just add a 3 to each side. So you have a equals d minus b over h plus 3. B over h plus 3. All right. Next problem here. So the next section was dealing with applications of linear equations, or a fancy way of talking about word problems, which is always the part of the exam that students end up dreading the most there. All right. Just because the hardest part with these types of problems is translating from the English to the mathematical statement. Once you have the mathematical statement, then it's just like we've been doing in all the other problems so far. So the only really difference here is instead of having the mathematical statement given to us, we have to deduce it from the problem here. All right, so here you have a carpenter used 32 feet of molding in 3 pieces to turn a garage door. So if the long piece was 4 feet longer than twice the length of each shorter piece, then how long was each piece on there? All right, so in this case, we have a 3-sided figure. Since again, we aren't putting crown molding on the bottom of our garage door, so it's just going around the 3 sides. All right, and here we have my short side here is going to be x. And we have the long piece was 4 feet longer than twice the length of the shorter piece. All right, so we have 4 feet longer, so that means we're going to be adding 4 to twice the length of the shorter piece, which is going to be 2x. So this long piece here is going to have the length 2x plus 4. And this is also going to have the length x. Since garage doors they're rectangles, so the opposite sides are going to be the same length. All right. And we have the total number. So the total amount of crown molding that was used was 32 feet. So when I add up these 3 things together, I end up with 32 feet. All right, so you have x plus 2x plus 4 plus x equals 32. All right. So this is the mathematical statement that I'm trying to solve in this problem. So again, once you get to this point, it's just a matter of solving your equation there. So again, we can combine like terms. So we have several terms involving an x over on the left-hand side. So we can combine those into 4x plus 4 equals 32. Then we can subtract a 4 from each side. So you have 4x equals 28. And then we can divide both sides by 4. So we end up with x equals 7. All right. And again, once we get to this point, we think we're done and we get really excited because we've solved the problem. But however, again, we have to ask ourselves the two questions. So the first question we have to ask ourselves all the time is, does our answer make sense? Does it fit the physical constraints of my problem? In this case, I'm looking, so x represents the length. So in this case, I'm looking for a positive number x. That's kind of the main thing that I'm worried about, is if I end up with a negative number for x, then I might need to go back and check my math. In this case, it is a positive number, so it passes the first test. All right, the second test that we have to run is, does it actually answer what the original problem is asking? So again, if we go back to the original problem, it says, how long was each piece? So again, x represents the length of the shorter piece. All right, so each shorter piece was 7 feet long. But we also need to figure out the length for the longer piece. Thankfully, once you know one of your variables, it's pretty easy to find solve for the other variable. So I can just plug a 7 in for x there. So 2 times 7 is going to be 14, plus 4 is going to be 18 feet long for the longer piece. And that's all there is to it. So again, it may look overwhelming at first, but if you just kind of take it apart, it's not too bad in the end. All right. So here we have a mixture problem. So this is how many gallons of an 80% antifreeze solution must be mixed with 70 gallons of a 20% antifreeze to get a mixture that is 70% antifreeze. And it says use the 6-step method. I don't care if you use the 6-step method. To be honest, I'm not even sure what the 6-step method is. I feel like we're probably using the 6-step method without even really realizing it and formulating it explicitly there. All right. So again, generally how I go about solving this is I create a diagram. Again, this is just how I learned how to do these types of problems. Just kind of helps me visualize, keep track of my variables, what have you. All right, so here we have an 80% antifreeze solution. And that is what we're trying to figure out. So we don't know the volume of that. All right, we're mixing it up with 70 gallons of a 20% antifreeze solution. And we want to end up with a mixture that is 70% antifreeze. And the volume for this final mixture is going to be 70 plus X. So it's going to be 7 gallons plus however many gallons we mix up there. All right. So then to get my equation, I'm just going to take my percentage and multiply it times my volume. So I take my concentration, multiply it by your volume. And you can convert these to a decimal if you want. I'm not going to. I'm going to just leave it as a percentage. We have 80x plus 20 times 70. As long as you're consistent all the way through, so as long as you either convert to a decimal for each one of these, or you leave it as a whole number there, either way, you end up with the same answer at the end. All right, so you have 70 times 70 plus x. All right. So you have 80x plus 20 times 70 is going to be 1400 equals, and if I distribute the 70 through, I end up with 4900, 70 times 70 plus 70x. All right. So I'm just going to, again, get the x's all by themselves and the constants all by themselves. So I'm subtract 70x from each side, subtract 1400. You end up with 10x equals 4900 minus 1400, which would be 3500, I believe. And then again, once you have that, you can just divide both sides by your coefficient. So you end up with x equals 350. All right. And again, once you get to this point, you have to ask yourselves the two questions. First question is, does the answer make sense? Is it physically reasonable? Again, in this case, the main thing we're worried about is if we end up with a negative number at the end, which in this case we don't. So kind of checks that first thing. And the second question you have to ask yourself is, does it actually answer what the original problem is asking? So the original problem is asking for the amount of an 80% solution, which is what x represents in my formulation for the problem. So, all right, we are good to go. So we have 350 gallons. All right. Okay, so the next one here is dealing with a work rate problem. So again, the main formula to keep in mind here is we have the amount of work done equals rate times time. All right. So person X can clean up all the crime in the city in 4 hours working alone. Person Y can do the same job alone in 10 hours. So if person Y starts crime fighting at 8 a.m. and then person X joins him at 11 a.m., at what time will they have all the crime cleaned up? All right. So we have person Y who can clean up 1/10 of the crime per hour. So again, to find your rates, you're just going to take the amount of time and just take the reciprocal of that. All right. So we have for A, so the amount of cities that we're cleaning up the crime for is 1. So we have 1 equals, all right, and then person Y works by himself for 3 hours. All right, so we have 1/10, so that's his rate, times the amount of time that he works by himself, which is 3 hours there. All right, and then person X joins him. So together, they can clean, so person X can clean 1/4 of the crime in the city per hour. So we have 1/4, and then person Y can clean 1/10. So together they can clean the sum of that. All right. And in this case, we don't know the time. So that is what we're trying to find here. All right. So we have 1 equals 3/10 plus, all right. So in this case, our least common denominator here is going to be 20, it looks like. So 1/4 is going to be 5/20ths. 1/10 is going to be 2/20ths. So we have 7/20ths times t. All right. So then to get t by itself, we're just going to subtract the 3/10 from each side. So this, so 1, which is 10/10 minus 3/10 is going to be 7/10. That's going to equal 7 over 20 times t. All right, and then to get t by itself, we can just multiply again both sides by the reciprocal of my fraction, or the reciprocal of my coefficient there. So 7 and 20 cancel. Here the 7 and the 20 will cancel. All right, and 10 goes into 20 twice. So you end up with 2 equals t. All right. And again, at this point, we need to ask ourselves the two questions. The first question, does the answer make sense? In this case, we end up with a positive number. Again, the main thing we need to worry about is if we end up with a negative number, and there's no mention of a DeLorean with flux capacitor traveling 88 miles per hour, or a time turner, or a, pretty sure Doctor Who has this thing called the TARDIS, which I think is a time traveling thing. I don't know. I've seen like 2 episodes of Doctor Who, but anyway, that's not here and there. All right, in this case, we end up with a positive number, so that's fine. The second question we need to ask ourselves is, does it actually answer what the original problem is asking? So again, T represents the amount of time that they're working together. So we're asked, what time will they have all the crime cleaned up? All right, so in this case, they've been working for 3, so person Y was working for 3 hours alone, and then 2 hours with person X. All right, so we have 3 plus 2, so that's 5 hours, starting at 8 a.m. So if you do 8 a.m. plus 4 would be 12 noon, and then 5 would be 1 p.m. All right. All right, so the next problem here is dealing with distance and midpoint formula. There are 2 formulas that you just kind of need to have memorized for this exam. So the distance formula is using Pythagorean theorem. So you have x1 minus x2 squared plus y1 minus y2 squared, and then take the square of that. And midpoint is just going to be, so the x1 is going to be the average of your x values, x1 plus x2 over 2, and then the y coordinate is going to be the average of your y values. All right, so those are kind of the 2 formulas that you just kind of need to have down. All right, so here we have my 2 points are -8, 4, and 7, -32. All right, so the distance is going to be the square root of x1, which is going to be -8, minus x2, which is going to be 7 squared. And then so we have plus y1, which is going to be 4, minus a -32. So minus y2 squared. All right. Just doing some of the arithmetic here. So -8 minus 7 is going to be -15 squared, plus 4 minus a -32, which is going to be 36 squared. So if I take -15 squared plus 36 squared, I end up with the square root of 1521. Okay. Where's the square root? There we go. Which ends up being 39. So that is my distance. Again, distance is just going to get you a number. And then the midpoint is going to get you a point. So in this case, the midpoint, you're looking for both an x and a y coordinate. All right, so the midpoint here is going to be the average of your x values. So you take -8 plus 7 over 2. And then the average of your y values. So 4 plus a -32 over 2. And again, just doing the arithmetic here. Your -8 plus 7, so that's going to be -1/2. And then 4 plus a -32, so that's going to be -28 over 2, which is going to be -14. All right. So we have -1/2, -14. All right. So this next one here is dealing with the equation for a circle. So I will not ask you to graph a circle. I told you that I probably wasn't going to ask you to graph a circle. So the main thing I want to ask is convert from general form to central radius form. Unfortunately, the Pearson website didn't have any questions dealing specifically with that, so this was the closest I could find for that. All right. So you have x squared plus y squared equals negative 3x minus 4y. All right, so to start off, we're going to add 3x, so we're going to get our variables by themselves on one side and a constant over on the other side. So you have x squared plus 3x plus y squared plus 4y equals 0. All right. And then we're just going to go through the process again of what's known as completing the square. All right, so to complete the square, you start off. So in this case, we're going to complete the square twice. All right, so we're just going to start off with the x part here. So you have your variable plus, and then again, you're just going to take 1/2 of whatever the coefficient is in front of your variable raised to the first power. So 1/2 of 3 is going to be 3/2, and you're just going to square that. All right, so when I FOIL this out again, I'm going to have x times x, so that's going to be the x squared, plus 3/2x plus 3/2x, that's going to give me plus 3x. Then I'm also going to have plus 3/2 times 3/2. I'm also going to have plus 9/4. So again, what you're adding is you're just adding your constant terms squared. And again, if I add 9/4 to one side, I have to add 9/4 to the other side as well. All right, and then we're going to assume a thing with our y. So we have y plus, and again, we're going to take 1/2 whatever the coefficient is in front of our linear variable. So 1/2 of 4 in this case is going to be 2. And then when I square that, I'm going to end up with 4. So I'm going to add 4 to each side. All right. So we have 9/4 plus 4. So 9/4 plus, let's see, that would be 16/4. That would be 25/4. All right. And yeah, so on the exam, I'll ask you to find the center radius form, and then state the center and radius for your circle there. So in this case, the center is going to be, again, center radius form is we have x minus h squared plus y minus k squared equals r squared, where h and k are the x and y coordinates of my center respectively, and then r is my radius. All right, so again, you're going to keep the same numbers, but you're going to take the opposite signs. Again, we're subtracting the h and the k. All right, so you get negative 3/2 and negative 2. And then the radius is going to be the square root of your constant term. So square root of 25/4. If you have the square root of a fraction, you can just take the square root of the numerator and the square root of the denominator. So square root of 25/4 is going to be the square root of 25 divided by the square root of 4. Got ahead of myself a little bit. All right, which would be 5/2. All right, so that is what I would be asking. In this case, it asks us to graph it. Oh boy. Okay. Okay, so in this case, you want the center at negative 3/2, so that's negative 1.5. All right, negative 2. Okay, that's perfect. And then our radius is going to be 5/2. So if I take negative 3/2 plus 5/2, I might end up with 2/2 or 1. And the largest it should be is that 1. Y value should be, wait a minute, getting ahead of myself. Well, getting behind myself. All right, so if you take negative 3/2 plus my radius, so that means that I should move to the right until I get to 1. That. Again, I want to ask you to actually graph it on the exam, but that's how you do it. All right. All right, so this last question here is dealing with the equation for a line given 2 points. All right, so we have point -2, -2, and 2, 12. All right. All right, so again, I'm going to start off by finding the point slope form, even though that was like the one form that they did not ask for in the problem, which would be y minus y1 equals m times the quantity x minus x1. All right. So in this case, y1 is going to be the y coordinate for my first variable, so that's going to be -2, and the x1 is going to be the first x coordinate for my first point, which should also be -2. Again, you could also use this as your y1 and x1 again, as long as you're consistent. So you can't mix and match the points. So I can't choose like my y coordinate on my first point and the x coordinate on my second point. So I have to remain consistent as far as the points go. All right, so then we have m, which is my slope, is going to be the change in your y values. So that's going to be y2 minus y1 divided by x2 minus x1. So divided by the change in my x values. All right, so here we have y2 is going to be 12 minus y1, which is going to be -2, divided by x2, which is going to be 2, minus x1, which is going to be -2. So we have 12 minus a -2, so that's going to be +2, so that's going to be 14. And then 2 minus a -2 is going to be 4, which has a common factor of 2. So we have 7/2 as my slope. All right. So we have y minus y1. So y minus a -2 is going to be y plus 2 equals my slope, which is 7/2. Times x minus x1, which is x minus a -2, which is going to be x plus 2. All right, so again, on an exam, I'm fine if you leave it in this form. If you choose not to, if you choose to use the other forms, again, as long as you have the correct equation at the end, I don't really care which form you use. So yeah. In this case, it does want it in point slope form. Okay, so it did want it in that one. All right, perfect. So you have y plus 2 equals 7/2 times x plus 2. In this case, it also wants the slope-intercept form as well on the practice exam. Again, there wasn't a question that I found on the Pearson website that asked for the slope-intercept form for the equation of a line between 2 points without asking for the so the point slope form of the equation for a line between 2 points without asking for the slope-intercept form. So yeah, so kind of limited as to the pool of questions that I can use, which is one of the drawbacks of using the Pearson website for these. But I do like the fact that you, again, have the ability to ask for a similar problem, so you have an infinite amount of practice problems to choose from, as opposed to if I wrote a practice exam where you just have the single practice problem on the exam, unless you formulate your own, which in this case is not too bad to formulate your own. All right, anyway. I get distracted easily. All right, as you know. All right, so my next step here is I'm just going to convert this to slope-intercept form. So I'm going to go ahead and use a different color for this. So to get slope-intercept form, you're going to end up with y equaling something. All right, so here I'm going to subtract a 2 from each side, and then distribute the 7/2 through to the x and the plus 2. So you have 7/2x plus 7. Because 7/2 times 2, the 2's will cancel, so we're left with 7. And then minus 2. So you have 7/2x plus 5. There we go. So that is my slope-intercept form. So you have y equals 7/2x plus 5. All right. I think that's everything. So I'm going to go ahead and submit and see how we did. I always get really nervous whenever I push them. Did I forget something? Did I make a silly mistake? Because yeah, there have been times where I have made silly mistakes, so I'm by no means immune to that. But in this case, everything looks on the up and up. So yeah, so again, just some kind of notes on practice exam in general. So generally I put more problems on the practice exam than on the actual exam. So if you're overwhelmed by the amount of problems on the practice exam, don't worry too much. The actual exam will probably be a few less problems. But again, I'm not quite sure what types of problems I'll be asking, and I make a couple different copies of the exam, so I shift the types of problems or the exact problems that I'm asking for the different students. So I want to kind of cover my bases with regards to that. Also, again, this is just how I go about solving the problems. There are many different ways that you can solve problems in mathematics. So if you have a way that makes more sense to you, again, as long as you arrive at the correct answer, you can go ahead and use that way, your own way as well. You can go your own way. All right. Let's see. Other than that, yeah, I think that's pretty much it. So yeah, hopefully you found this helpful. Have a lovely day, and I will talk to you all later. Bye now.